Seeing Earth from space has forever transformed how we understand our home planet. For the first time, humanity can look at Earth as a single, living system, where the atmosphere, oceans, land, and all forms of life constantly interact. Our planet is not static. Earth's atmosphere, hydrosphere, geosphere, and biosphere are in motion, changing every day, even every second. By monitoring Earth in near real time, scientists can capture an up-to-date view of its shifting conditions and the balance that sustains life. 9 planets orbit an average-sized star in the Milky Way, the Sun. The third planet, our Earth, is positioned between Venus and Mars, our closest neighbors. At first glance, they seem similar, yet a closer look shows how unique Earth truly is. Venus, almost equal to Earth in size and gravity, has a dense atmosphere made mostly of carbon dioxide, with nearly no water. Its surface scorches at more than 800 degrees Fahrenheit, hot enough to melt lead. Mars, by contrast, is half the size of Earth with a thin, cold atmosphere. Temperatures can plunge to minus 190 degrees Fahrenheit, and water exists only as ice at the poles or possibly beneath its surface. Earth stands apart. Liquid water covers 70% of its surface, and the air is rich with oxygen and water vapor. It is geologically alive, shaped by volcanic eruptions, plate movement, and weather, but most of all, it's the only world known to host diverse life. From orbit, spacecraft and satellites have completely changed our perspective. We now see Earth's oceans, land, atmosphere, and ecosystems as interconnected global systems. The sun powers it all. Its energy warms the oceans, the land, and the air above. The oceans store heat and move it across the planet through powerful currents, releasing it back into the atmosphere. This exchange drives winds, clouds, and the weather patterns we experience every day. At any moment, about 40% of Earth's surface is covered by clouds. From space, we can watch these swirling white patterns that trace our planet's wind belts, broad zones that define the climate of each region. Water vapor, the invisible gas in the air, is a key player in shaping our weather. In time-lapse views, we can watch giant storms twist across the oceans. The hurricanes of 1995, for example, began off Africa's coast, then swept across the Atlantic toward the Caribbean and the U.S. East Coast. Earth's climate is also influenced by how heat is distributed in the oceans. Satellite maps reveal global sea surface temperatures, red for warm waters, blue for cold. When warm water replaces cooler water in the eastern Pacific, scientists call it El Niño. This event can disrupt the weather worldwide, triggering floods, droughts, and temperature shifts across continents. Beneath the oceans and continents, the solid Earth is constantly shifting and reshaping itself. If we could drain away all the oceans, we'd see a dramatic landscape of towering ridges, deep trenches, and massive fracture zones that stretch for thousands of miles. These features reveal that Earth's crust is not one continuous shell, but a mosaic of gigantic plates floating on the molten mantle below. As these plates slowly drift, they collide, separate, and grind past one another. When plates push together, mountain ranges rise. When they pull apart, new ocean floor forms, and when they slide past, earthquakes shake the planet. From 1980 to 1995, scientists recorded thousands of earthquakes greater than magnitude 4.5. Plotted on a world map, they trace glowing yellow lines that perfectly outline the boundaries of these tectonic plates. Along these same regions where oceanic plates are forced under continental ones, rock melts deep underground. The molten material, lighter than the solid rock around it, rises to the surface and erupts as volcanoes. Red triangles on the map mark volcanoes that erupted between 1960 and 1995, forming fiery chains around the Pacific known as the Ring of Fire. This restless movement of Earth's crust is a reminder that our planet is still geologically alive, reshaping itself in cycles of destruction and renewal. While the solid Earth moves beneath our feet, the surface above is full of motion too: winds, ocean currents, and the rhythm of life itself. The combined forces of the oceans, atmosphere, and land create the delicate balance that sustains life. Patterns of topography, temperature, and rainfall decide where deserts form and where lush forests thrive. Satellite data show these living patterns change with the seasons. In spring and summer, the continents glow green as plants and trees burst to life. In autumn and winter, those same regions fade to brown and gold as the growing season ends. This pulse of greening and fatting is like Earth's heartbeat, a visual signature of life that can be seen from space. Other parts of the planet, such as the vast deserts of North Africa, the Arabian Peninsula, and Central Asia, remain shades of tan and yellow year-round, harsh landscapes nearly devoid of vegetation. Yet even these regions play an important role in the global system, sending mineral-rich dust into the atmosphere that fertilizes distant oceans and forests. At night, another view of our planet emerges. City lights sparkle across the continents, bright threads of human civilization visible from orbit. Each glowing cluster marks the presence of people, energy, and progress. Flickers of red and yellow light show fires from agriculture, industry, and the burning of fossil fuels. From space, we see the unmistakable fingerprint of human activity, spreading across nearly every corner of Earth. Today, satellites orbiting Earth collect vast streams of data every hour, monitoring the oceans, the air, the land, and even the tiny changes in vegetation and temperature that reveal how the planet is evolving. This global monitoring allows scientists to understand how Earth systems are linked, how air affects water, how land shapes weather, and how life responds to both natural and human change. Seeing Earth as a whole gives us more than just data, it gives us perspective. It reminds us that every cloud, forest, ocean current, and city light is part of one vast living system. Only by viewing our planet globally can we truly appreciate its beauty, its power, and its fragility. Earth is not just where we live, it is a dynamic, interconnected world, the only home we know and one that we share with all life.